Let's be honest, shifting our entire planet to renewable energy is one of the biggest challenges we've ever faced. I mean, it's a massive puzzle of engineering, economics, and logistics. But what if there was a new, incredibly powerful tool that could help us manage all that complexity? Well, that tool is here, and it's artificial intelligence. So let's dive in. And this is not some far-off sci-fi concept. It's happening right now, and it is happening fast. Just look at that number. By 2034, the market for AI and renewable energy is projected to hit a staggering $78.2 billion. That tells you everything you need to know. This isn't just a cool idea. It's a massive economic and technological wave that's already starting to crest. And this chart, this is what really shows you the sheer speed of this thing. We're talking about nearly 10 times growth in just a single decade, from about 8 billion this year to over 78 billion. It's an explosive adoption curve that's about to completely reshape the entire energy sector. So you have to ask, why is all this happening? Why the sudden rush? Well, to really get the solution, you first have to appreciate the scale of the problem. You see, the road to a net zero world is incredibly complicated. It's not as simple as just putting up more solar panels and wind turbines, not by a long shot. And here's a really crucial point, pulled right from the source material. Our clean energy future has a very real, very physical cost. To build all of this new stuff, the batteries, the grids, the turbines, it creates this huge new demand for specific minerals. It basically turns the energy sector into one of the biggest players in those global markets overnight. This diagram really gives you a powerful picture of that flow. Our green future is literally built from things like lithium, cobalt, nickel, and copper. Electric cars, massive battery storage farms, even the grid itself, they are all incredibly hungry for these materials. In one scenario that aligns with the Paris Agreement, the demand for lithium alone could jump by almost 90%. Trying to manage that global supply chain is just a monumental task. So if that's the problem, this massive physical world challenge, how do you solve it? Well, this is exactly where AI comes into the picture. It's kind of like the missing piece of the puzzle. It's a digital intelligence that is perfectly suited to manage the very physical complexity we've just been talking about. So what can it actually do? Well, get this. It can predict cloud cover with insane accuracy, telling a solar farm exactly how much juice it's going to generate. It can instantly reroute power to stop or blackout before it even starts. It can manage huge networks of batteries, storing solar power from lunchtime to use when we're all cooking dinner. And it can even help us discover brand new materials for better, cheaper batteries. It's like a multi-talented digital co-pilot for the entire energy system. But for AI to work its magic, it needs fuel. And in this case, that fuel is data. Big data, to be specific. The best way to think about it is as the nervous system of the modern grid. We're talking billions of data points flowing in from smart meters, sensors, and power plants every second, giving us a live picture of exactly what's going on. And this slide really shows you just how widespread that nervous system is. You can see how data is woven into every single part of electricity's journey, from the second it's generated all the way to the moment you flip a switch in your home. Let's just trace that path really quickly. It all starts at generation, using data to make power plants run better. Then it moves to transmission, where it keeps the power flowing smoothly across the country. Next up is distribution, getting that power into our neighborhoods. And finally, it's about demand, where data can help all of us use energy a bit smarter. It's a whole data-driven ecosystem. Okay, so if big data is the fuel, what are the engines? Well, we're now seeing this new generation of advanced AI that can do way more than just crunch numbers. You should think of them as a powerful new toolkit for the energy sector. First up in the toolkit, we have large language models, or LLMs. And you've probably heard of these from tools like ChatGPT. For our purposes, think of an LLM as a brilliant research assistant. It can read and make sense of thousands of scientific papers, complicated operational reports, and market data to find insights no human ever could. And this right here is the engine inside that research assistant. Now, it looks complex, I know, but at its heart is something called a transformer architecture. It's what powers a lot of today's AI. The important thing is that it can take in tons of information, process it through all those layers, and then generate something new. This is what lets it connect dots across huge amounts of data, which is a total game changer for research and development. But what if the AI could do more than just analyze? What if it could actually act on its findings? Well, that's the next tool in the box, Agentic AI. This is a big step up in autonomy.
If an LLM is a research assistant, then an agentic AI is more like an autonomous pilot for the power grid, able to make its own decisions to hit specific goals.
And here's kind of how that pilot would work. It gets a task, something like figure out how a heat wave will affect the grid. It can then go off on its own, choose the right software to use, run a bunch of simulations, analyze the results, and even write up a report. But, and this is the crucial part, you see that little pause for human permission? The system is designed to always keep an expert in the loop for the big decisions.
Okay, so this all sounds pretty incredible, right? Almost like science fiction. But we have to be realistic here. Handing over this much power and autonomy to an AI system, well, it opens up a whole new can of worms, a new set of challenges and risks that we absolutely have to tackle head on.
And the source material lays out 6 big ones. You've got fundamental issues with data, you've got huge privacy and security worries, there's the risk that an agentic AI could just do something unpredictable. Then there's the fact that LLMs can sometimes hallucinate, literally just make things up. And of course, there are big questions about safety. And the final irony? The massive amount of energy it takes to run these powerful AI models in the first place.
But look, these challenges aren't deal breakers. Not at all. In fact, just knowing what they are is the first step to solving them. So the real question is, what's the path forward? How do we take all this amazing potential and manage the risks so we can build an energy system that's truly intelligent and sustainable?
Well, the research community is already on it. They're working on things like new hybrid data systems and creating frameworks to make AI safer and easier to understand. They're trying to make LLMs more accurate. My favorite idea here is the digital twin. It's basically a virtual copy of the power grid where you can train and test AI safely before letting it loose in the real world. And critically, we have to make the AI itself use less energy.
Because when you take a step back and look at the big picture, this whole conversation isn't really just about algorithms and data centers. It's about using our smartest tools to solve some of our biggest global problems. In fact, using AI for the energy transition directly helps us hit at least 5 of the UN's Sustainable Development Goals. It's right at the heart of affordable and clean energy. It fuels innovation. It helps us build sustainable cities. It promotes responsible consumption. And of course, it's a vital tool for climate action. This technology is tied directly to the kind of future we're all trying to build.
So here we are, at a kind of crossroads. AI is offering us this powerful new path toward a clean, stable energy future. And the tech is moving faster than any of us could have imagined. Really, the only question left is, will we have the foresight and the wisdom to walk that path responsibly?